So the first one is diazenonyl tetrapolyhexafluoroantimonate, and the reason it's cursed is because, well, first of all, look at it. Second of all, it's a radical. And third of all things that has an unpaired electron, it's a xenon. Why? Just why? I would say that this one is less cursed because it's a chemo drug and it helps people with cancer. But what's cursed about it is it has ammonia attached to platinum dichloride. Platinum doesn't usually like to be oxidized unless by oxygen, chlorine, or fluorine. And it also is just 2+, which is even worse. This one isn't that cursed, apart from the fact that it's just an 8 ring of sulfur, which is wrong, but apart from that, it's not very cursed. So this one is pretty cursed because phosphorus and hydrogen have very similar electronegativities, which means that it's actually quite debated whether it's in a +5, +3, or +1 oxidation state. So here we have fluoroboric acid, which isn't super cursed, but it is an adduct of hydrogen fluoride and boron trifluoride, which makes it cursed. This one is cursed because it's a radical, and radicals are immediately cursed. But it's also cursed because it's an oxygen fluoride, and oxygen fluorides are automatically cursed. Here we have protonated ozone, which is cursed just because, how do you manage to protonate ozone? This one is pretty cursed because technically oxonium is an electrophile and water can act as a nucleophile, so yes, this can exist, but it's more of just an intermediate, similar to oxonium. Sodium carboxide is cursed because it can act as an intermediate when sodium reacts with carbon monoxide, but it can also just be produced when sodium reacts with formaldehyde. Sodium nitroxide is cursed. It can be formed when you mix sodium with nitroxyl, which acts as a weak acid, and its formula is also pretty cursed. Okay, sodium bifluoride isn't really that cursed because it doesn't even technically exist. It's actually just sodium fluoride and hydrogen fluoride next to each other in solution. So this one is cursed because not only is it a strong oxidizer, but also in the paper I originally found it in, it was labeled as fluorine fluorosulfate, which is wrong because fluorine cannot be oxidized except theoretically by helium and neon, but even that's ugh. This one is cursed because technically it's an adduct of gold methyl and trimethylamine, which is just wrong because in this case the gold should have a very, very slight positive charge, but it has a negative charge, which means this can't last long. So this one is just, I don't even know anymore, because yes, technically xenon has lone pairs, and yes, it can attach to things, but it's still wrong. It's like taking the two of the most inert elements and forcing them into a compound which doesn't even technically exist. That's just adding insult to injury, in my opinion. This one is just absolutely ridiculous because not only do you have mixed anhydrides, but also you have strong oxidizers, and I can only imagine how violent this would be if it touches water. I don't even know what this one is. It looks to me as if some college student was just screwing around with different amounts of singlet oxygen and sulfuric acid. That's crazy. So this one isn't actually that cursed because it's just super useful in organic chemistry. It's sort of just a simple adduct of hydrogen chloride, chromium trioxide, and pyridine. So it's really not that cursed if you think about it. This one is unbelievably cursed, not only because of its dimeric structure, but also because it's such a high oxidation state for such an inert metal. Of course, fluorine. Of course. You had to do this, didn't you? This one is pretty cursed because you don't usually think of alkali metals forming complexes. Basically, you can make this when you add sodium metal to liquid ammonia, and you'll have something called an electride, which is when the electron is just freely flowing through the solution, which is cool but also just wrong at the same time. So if sodium nitrate is a 1-to-1 mixture of sodium oxide and nitrogen pentoxide, what happens if you tweak the ratio? Well, this is what happens. It's so wrong, and I can easily see it taking water out of absolutely everything and oxidizing the crap out of, like, even asphalt. This one is only cursed if you don't understand it. So basically, the oxygen puts itself between the phosphorus since it bonds with two things, and then you have the lone pairs, which also get attacked by oxygen, and then boom. This one is cursed only because it's just wrong. Also, it's linear, which feels wrong. And when you put it in water, it reacts, releasing methane and explodes. So this one is just, Basically, you can make it by mixing sulfur trioxide, hydrogen fluoride, and antimony pentafluoride, but in a different ratio, so it's not exactly the same as magic acid. This one is just the trimer of cyanic acid, but some people find it cursed. Much like cyanic and isocyanic acids are different tautomers of each other, isocyanuric acid is a different tautomer of cyanuric acid. This one is wrong because there are so many cations, because there are so many oxygen attached to the rhodium, and because the rhodium is in an unusual +5 oxidation state. Honestly, at this point, it's just oxygen and fluorine fucking around with shit and doing their thing. Here we go again. It's a trimer of fulminic acid. Woohoo! Nice! Thanks for watching. If you like this video, maybe you should look at some other videos I made. You don't have to, obviously. And if you have any ideas for videos, please post them in the comments. Thank you.